Hey, what's going on, guys? Again, I had another few questions asking about some of these problems on worksheet 3, and actually, I had a couple here on worksheet 4. I don't know if I'll go over the worksheet 4s, but I will give you the formulas for the worksheet. So, just in case you missed them during the notes. So right here, the first thing that I want you to do is, if you haven't already, go ahead and write down these formulas. So these formulas are necessary for you guys to be able to do the quiz, right? Um, the sum of the interior angles, so all of the angles, right? The sum of the interior angles, that means all of them, will always be n minus 2 times 180. And remember that n is the number of sides. Every time. Always. It's always going to be the number of sides. To find just one angle, well, on a regular polygon, right, if you're looking for one interior angle, well, that means that we have to do two things. First, you have to find the total sum. Notice that that's the same as here. So you'll find the sum, and then you'll divide it by the number of sides that we have. And why are we doing that? Well, because it's going to give us the measure of one interior angle, just one of them, right? If we have the total and divided by the number of sides or the number of angles that we have, right? Because the number of angles is the amount of sides, then you will get the measure of one. That's this formula. Now, if you remember during the notes, I said the sum of all of the exterior angles will always, period, be 360. Always going to be 360. Whether that be a triangle, quadrilateral, anything, it does not matter. It will always be 360. So the exterior angles. And if you're looking for one of a regular polygon, the measure of one exterior angle, well, that's just 360 then divided by the number we have. The same way that the inside, we can do that. We can divide by the number that we have. We can do the exact same thing with the outside. Okay, so knowing that, let's go ahead. I'm just going to go over these. I went over these during class, um, and this is how we would do it, right? We have our area formula, and actually, I'll go ahead and rewrite this a little clearer because I did this standing up, right? So if my area, I said area, but my angles. So if I'm looking for an interior angle, so let's just say one angle, right? Then what we would need is we need the total amounts that we have for our polygon times 180, and that's divided by the number that we have, n. So what would we plug into this equation? Well, if we're looking for the number of sides, we're looking for n, that means we have to plug in this, right? 144. So instead of writing one angle here, I'm going to go ahead and erase that. Feel free to rewrite it yourself. But we're going to go ahead and plug that into the one angle because we had one angle measure being 144. And now we have to solve for n. But how do we do that when we have an n on the top inside of a parentheses and one at the bottom? Well, the first thing is, well, we have to bring this n up. And the only way we can do that, I mean, there's a couple of ways, but the most simplest way is, since I know this is being divided by n, I know I have to multiply by n. So I'm going to go ahead and just multiply this by n. I'm going to multiply this by n. So then when we simplify this, we get 144n. And actually, let me rewrite that, 144n. And that's going to equal, these cancel out. I'm left with n minus 2 times 180. Now, how did I get this bottom part from that? Well, this is the exact same thing as if I had 180 times n minus 2, which we know when we see something like this, we can distribute. So I just distributed backwards. Not backwards, but I went from the right side instead of the left side. So 180 times n is 180n. 180 times negative 2 is negative 360. From here, you can go ahead and just solve it, right? You'll subtract 180 n minus 180 n, and that should be, I believe, 36n negative to negative 360. And I think you can see what the answer is going to be from here, right? N is going to equal to 10. Great. Okay. Knowing that, you should be able to now do 6. Right? Because it's a little easier because here they told us the sum. So here, the formula that you would use is just this top one where the sum of the angles is equal to n times minus 2 times 180. And then I just decided, let me try dividing by 180 here to get 9 equals n minus 2. And then you just solve from there. All right, so this was a little bit more simple than number 5. Um, but notice that you end up having this almost this exact same thing. You can always divide again by 180 here, or you can do that distribution that we did, and you'll get the exact same answer. Okay, with that, I did want to go over, I think maybe 8, 9, 10, but we'll see. So here, if the area of the, so here they tell us that the area of the triangle is 93 centimeters squared, and we're trying to find the height. Now, again, this is where a lot of students get really confused. Some students think, well, if we're looking for the height, that means I have to find this, right? No, that's the length of that of the longest side. We're trying to find the height. So from the tippity top to the ground, tippity top to the ground. So I'm going to make a 90-degree angle here. That's an altitude, if you guys remember. We're trying to find this height. And the base is not going to be from here to here, right? Because I don't care. That's not part of the triangle. Only part of the triangle is the only parts of the triangle with a base is this 12 here. So if this is 12, then this has to be my base. This is just an extension that we made to make things easier for us to find the height. But that's not actually there. So no, now we do know that the total interior length would be 93 centimeters squared. Well, let's go ahead and use our equation. If my equation of a triangle is area is base times height divided by 2, then I just have to plug in my knowns. So my known here is my area. My known here is my base, and everything else goes in. And again, there's 2 ways you can solve for this. You can either multiply by 2, or in my case, I'm just going to go ahead and divide 12h by 2. If I had 12 h's, I divided them by 2. That would mean I would have 6 h's. And now we can just divide by 6. And so we should have, let me bring out my calculator. We'll go 93 divided by 6. That is equal to 15.5. Okay, 15.5 equals my height. And this is centimeters if you really wanted to plug it in. So 15.5 centimeters. Done. Right, not too bad. Okay, now let's look at number 9. Uh, okay, so this is a rhombus. So we know a couple of things about rhombus. A lot of it is already, so the sides being congruent is already marked for us, but the important stuff that we kind of need to know isn't, right? So remember that the reason that a rhombus's sides are all congruent is because it's just tilted square. So one thing we need to remember about a rhombus is that these are 90-degree angles. Everything inside of it is 90 degree, right? Those diagonals, when they bisect each other, they're 90 degrees. And the fact they're bisecting each other means that they're cut in half, right? So if that means that this is, and this side here, these are congruent. So this is 3 inches, and this is going to be inches as well. And this is congruent to this part here, 6 inches as well. So remember that for a rhombus like this, a rhombus is pretty much just made up of 4 congruent triangles. And if you see here, the area of this one is going to be half of this square. This is also half of this rectangle. Sorry, not square. Half of this rectangle, half of this rectangle. So therefore, the area of this rhombus is almost the same thing as uh, it's very similar to that of a square, right? Or sorry, that of a triangle, because it's just made out of 4 different triangles. The area of a rhombus is just half of that total rectangle because each one of those quarters is half. So therefore, the total is half of the big rectangle. So how do we find that area? Well, this diagonal, remember, is the same length as this base. So therefore, diagonal 1, I'm going to say, is 6 plus 6. That gives me 12. And then this diagonal is the same thing as my height. And this is 3 plus 3. So diagonal 2 is 6. And therefore, my base times height divided by 2 is going to give me my rhombus, right? So the area is the diagonal 1 times diagonal 2 divided by 2. Area is 12 times 6 divided by 2, which should give you 36 inches squared. And that should be your answer, 36 inches squared. Right, nothing too bad so far. One more. And this one is the exact same concept as a rhombus. Exact same concept, right? Also going to be half of this rectangle, right? Because this is half, this is half, this is half, this is half. So it uses the same exact formula, d1 times d2 divided by 2. And not only that, but it has similar things, similar properties as a rhombus, just that only this short side here is going to be bisected. So this is 20, so therefore this here is 20. And this is 25, so this is 25. And I'm actually going to put 3 little check marks because they're all different. Now, this one's not too bad because I notice right away here, these are all right? The same properties as a rhombus where these are all right. So I have this triangle right here, right? I notice right away that this is 5 times 5. I notice this is 4 times 5. So therefore, this has to be a 3 times 5. It's a 3, 4, 5 triangle. So my length here has to be 15. Now, unless you're really good with your triples, you're going to get something here. So what I want you to do is you need to use the Pythagorean theorem for this one to find this length here. And then from there, you're going to be able to find, and I'm going to call this X, right, from this triangle. So I'm going to have you guys try this out. You have the key, right? But remember that your D1 is going to be 20 plus 20. Let's call this D1 right here. So that's 40. And then your D2, your diagonal 2, is going to be 15 plus whatever X is. And you need to use the Pythagorean theorem for that. So find out X, and then go ahead and plug those 2 diagonals into your formula, and you should get the answer. Your answer should be, I believe it's like 1,600 units squared. So try it out and see what you get. Now, with that, remember, so here we go. Let's go ahead and I'm just going to remind you, right? So for worksheet 4 here, the formula that you want to use here is the sum of the interiors. So for this one, you want to use n minus 2 times 180, and go ahead and try that out. For this one, you have one interior angle. So therefore, this formula here for number 3 is going to be the same as above, but just now divided by the number of angles that we have being n. And you'll find your one. I do have an example here. You can follow it along and finish it up. But I'm not going to do those in this video. For one exterior angle, remember, one exterior angle is just 360 because that's our total divided by the number that we had. And you should find that one as well. And that is it. So that's what I'm going to cover today in this video. If you guys have any more questions, please don't hesitate to ask. I'll see you guys tomorrow. Bye-bye.